Hello everyone, welcome back to the Essential SQL series. Today we are going to learn about a topic which is advanced, interesting and slightly complex but very important. Window functions. So what do the window functions do? Whenever we want to perform some calculations in the data for a smaller subset or a smaller portion, or in SQL terminology called as window, these functions are useful. We can actually divide the data to smaller portions using these functions and perform calculation and output the result at the same time, and you don't need to apply calculations separately and then merge the output. So let's look at these window functions first. Row number. So it will simply assign sequential row numbers to the data for each given window. Rank assigns a rank based on a certain sequence and follows the ranking concept, applying the same rank for the values that are equal. Dense rank is a slightly different version of rank function which outputs the rank the same way. However, it doesn't skip the next rank when more than one ranks are applied to multiple rows. Then comes percent rank or percentile rank. It provides a percentile rank of the rows in a given window. Cumulative distribution provides a cumulative distribution value for a given window. First value, last value and nth value outputs the first row, last row and the nth row of the specified window frame as the output. Entile divides the total data into multiple buckets or n number of buckets and provides the bucket number for each row. Lag and lead functions. So let's say we want to know what's the previous or preceding value for a given row, or the next or the following value for a given row. These lag and lead functions will help. Let's take a quick look at the syntax now. The syntax looks like this. Select window function, the name of the function that you want to use. In the bracket, specify the column name that you want to apply the window function to. Over partition by. Partition by is used to break down the data into smaller windows. Order by is used to order the data in a certain sequence to apply the ranking or range specially or the row numbers. Then range between start row and end row within the data frame from table name. Now let's look at this in practice. So in the first statement, we are going to see 5 things at a time. Let me first throw the output and then we will discuss the function in detail and how the output looks like. So here you can see the invoice ID and total, and for each of them you have certain values. Now let's look at row number first. So here row number, this is the function, always give an empty bracket here, use over, and since we are not partitioning the data right now, I'm not going to use partition by. So the data in each window has to be ordered by total in descending order. So the highest total gets row number 1, second highest gets 2. If two values are same, based on the order in the data, they are simply assigned the row numbers. So the row numbers are always going to be unique. Next comes rank. Since we are using again order by total descending, the highest value gets the first rank and so on. But when you can see, when two values are equal in total, the same rank is applied to both and the next rank is skipped because there are two. So if there were three values or more than three, you can see there are too many 13, so a lot of them will be skipped, and the next rank is 62 directly, and it ties with the row number. Then comes dense rank. Whenever dense rank is applied, after third rank, fourth rank is not skipped. The next rank applied here is fourth. And when there are too many 13s in rank, it is 9 here. And after 9, you will see there will be a 10. These three concepts are very important and are used very widely. The next two concepts, percentile rank and cumulative distribution, are not used so often but are again good to know. So what the percentile rank does is, based on the same order, it tells what is the percentile value from 0 to 1 for a given value, and mathematically you can see how the value is calculated. So let's open the calculator. The mathematical formula here would be simply the rank minus 1 divided by total number of rows minus 1. So for let's say 3, rank 3, I'll say 3 minus 1, which is 2, and 412 minus 1, 411. 2 divided by 411 gives you 0.4866, and you can see the value matches here. Similarly, for cumulative distribution, what it does is it provides the rank of a row based on how many values in the data are less than or equal to it. So let's take an example of these 13 here. So they are 61 values which are less than or equal to this value of 13.86, which will be our numerator, divided by total number of rows. Let's simply apply 61 divided by 412 and you will see the value here. So that is percentile rank and cumulative distribution. Let's now look at first value, last value and nth value. Let's discuss the functions first. So first value, what do you want as the output? We want the name from the albums. Over, now we see partition by. So what it will do is each album ID will be created as a separate window and you will be ordering by milliseconds. If you don't specify descending, ascending is default. And since we are using the partitions, we have to provide this statement called range between. So what is the range of data to be used within the window? Unbounded preceding means from the first value and unbounded following would be the last value. So wherever your value is in the data set or in the window, it will always consider the values from the first to the last value in the given window. If we don't specify that, it will not take it the right way. So what we are going to do is in each album, based on the milliseconds, we will see what are the first value, which is the smallest track, last value, which is the largest track, and nth value. So here after comma I specified 3, which is going to be the third smallest track. So let's see this. After that, we will see the tracks table and see how the values look like. In the album ID 1, you can see for each album ID there is only one row. The smallest track is COD in album ID 1. The largest is for those about to rock. We salute you. And the third smallest is put the finger on you. Now let's take a look at the data. First, let me sort by album ID milliseconds. So you can see the smallest is COD in album ID 1. The third smallest is put the finger on you, and the largest is for those about to rock. So that's about the first value, last value and nth value. This is again very important. Now let's look at end-tile function. First let's execute. You will be able to see and understand it easily. So you can see if we are doing partition by album ID again, ordering by milliseconds ascending again. In each album we are trying to divide the data by into 4 percentiles or 4 groups and 3 groups respectively. And for each album ID you will see the data is evenly divided and you will see the number of rows. So usually if the number is not equal, then the higher numbers like 3 and 4 are having less number of rows. So it will be doing like for 4 rows, it will first apply 4, then so on. So since in this album we had 10 rows and to divide 4, it did a 3 3 2 2 and you can see 1 2 3 4. When we divide it into 3, then you will see 1 1 1 1 2 2 2 and 3 3 3, and it will apply the same kind of entile to each and every album ID separately. Then finally comes lag and lead. There are a lot of instances where we want to compare the values with some previous values or the next values. So these lag and lead functions will help. So lag, we are trying to get the total from the previous row where we are ordering by invoice date. So from the previous invoice date, the lag here it will take only one row lag, but here it will take a two row lag. And if the value is null, it will automatically assign a 0 because we have given a comma 0 here. So let's look at the output. So here you can see we are ordering the data by invoice date, and the second row because of lag it is saying 1.98, but for here since we don't have anything and we didn't specify comma 0, it returns a null. But when we did a lag 2, you can see the first two are 0 because two preceding to this, two preceding to these are both zeros or nulls. So since we have assigned a 0, it is showing a 0 here. And for 5.94, the previous row is 3.96, two rows prior is 1.98. Similarly in the lead, we will go to the bottom of the data and you will see for 1.99 there is no value following, it is a null. 8.91, the following value is 13.86 and three following values are still 0. So for 5.94 we can see 1 2 and 3, it is 1.99, and since we specify a comma 0, the outputs are 0 instead of null. Since this is an advanced and slightly complex topic, I recommend you try this and use it thoroughly, as it will be very useful in your advanced analysis. On the top of these, you can also use the standard arithmetic functions like sum, average, count, min, max using these window functions. try it for yourself, practice a lot, keep learning. That's it for the video. Thank you.